All right, so with these angles, basically here's what we have. Because we talked about all the stuff with unit circle yesterday. We still got one small little thing to add to unit circle, but before we do that, got a few things we need to talk about here. All right, when we're talking about angles, we're talking about standard position, and because we've got to kind of know how things are drawn when they're going through stuff on this one. And standard position is basically this: when an angle has the vertex at the origin and one ray is on the positive x-axis. And when they're talking about that particular ray that's here, they're going to call that ray the initial side. Okay, the other ray can end where it wants to ever end. So the other ray is called the terminal side. Okay, so standard position has a vertex at the origin. One ray is on the positive x-axis. The other ray is called the terminal side. All right, so what that means basically is this. We go back to the unit circle yesterday. All right. So basically, here's what it means. When we were doing this yesterday, this will always be your initial side. So just giving you some kind of visual of what we're going through in this one. So whenever they're drawing an angle, you always have to have this as part of the angle. Now after that, it can be here, it can be here, it can be here, it can be anywhere along the way, but this always has to be the initial side. And usually what they're going to do is they're going to show you one of two things, whether it's a clockwise motion or counterclockwise. They'll either have an arrow drawn like this, or they'll have an arrow that's drawn like this, just to let you know which way this thing is going to go. So this would be your terminal side, or this could be your terminal angle over here. But again, you always have to start with this has to be given every single time. So whenever we're working through any of these, you have to have this angle going this way, or this side going this way. Now, what happens after that, again, it can be over here or back over here somewhere, but you have to have this one set up as you're going through this. Okay, and the way they're also going to show this one, if the arrow goes this way, it's going to be a positive angle. If the arrow goes this way, it's going to be a negative angle. So that's where we're talking about in the homework with some of the questions where they threw some negatives at you. That's basically what we're looking at. So positive from the initial side. If you go up from the initial side, it's going to be positive. Anything going down, it's going to be a negative. Because some of these are not going to give you they're not going to be on the unit circle. They're basically just going to be angles that are drawn. So this would basically be when you've got just an angle without any point of reference other than just what it has there. So positive angles are drawn up. From the initial side, and then negative angles are drawn down. All right, and again, when you're drawing those out, positive angle will have an arrow that's drawn up to let you know what's here. If it's a negative, they're going to have an arrow kind of headed down in that direction. Because without the arrow, you don't know exactly which way it's going to be when we go through some of these. Now, obviously, you're not going to have to sketch these. So what it's going to be most times, it's going to be a multiple choice question where they would ask you to sketch maybe a 30-degree angle. And they actually may or may not even have an XY axis on this one. But basically, all you're going to do is you're going to draw what would be your initial side, and then you're going to have an angle that's drawn something like this. And again, for them to show that it's based, because again, you've got two options. You could either go this way or you can go this way to get back to this side that's here. So what you have to do is when you draw these, again, if it's positive, that means you have to draw an arrow that's going to be something like that. So let you know that that's the particular angle that we're talking about and not this angle that's back here. Okay, so here's where we talked about what was some of the questions that popped up in the homework that got there a little bit early. So if you have to sketch a negative 30-degree angle, again, initial side will basically be here, just like it would be with this one. So this is still your initial side that's here. But now instead of going up 30 degrees, you're going to go down 30 degrees. Okay, and that's really the biggest difference. So if you've got something that's positive, your arrow has to go up to get there. If it's negative, you've got to come down. All right, now if they give you one that's in radian terms, it's not in degrees. And probably for the first little bit, this is probably what you're going to want to wind up doing as you go through some of these problems. That basically you just got to go back and find out where it is on the unit circle. So if it's sketching 3 pi over 2, basically just think that if you go through this one, that's the same thing as 270 degrees. If you go back and find that radian measure. So if you start with your initial side, okay, so then basically you're going to go until you get back around to 270 degrees, which would basically be here. If you'd have a sketch that would look something like that. Good. Again, the biggest thing is that, again, you have to have that arrow kind of showing, because if you don't have this arrow drawn in, you don't know if you're going this way or if you're going this way. So you have to have that arrow in there to let me know kind of what's going on with it. All right, one more. So let's sketch negative 5 pi over 4. Okay. Again, if you have to kind of find out what that one is, it's kind of good to kind of start getting those in your head. That would basically be negative 225 degrees, if you think about it in degrees terms. All right, so for here, if you go from here back to the middle, that would basically be 180 degree. It's going to go a little bit past that, so you basically should have something that would come up to somewhere along that line. So something like that. Yeah, but again, biggest thing is if it's positive, you're going to go in this direction to start with. If it's negative, you're going to go in this direction. All right, everybody okay with where? And again, that was popped up in the homework, and I got there a little bit sooner than I meant for it to. Everybody okay with the negative angles? Okay. All right, now here's where we're going to add in something that's kind of tied in with the positives and the negatives together. Is that the next thing that they kind of go with when we're talking about the angles is they're going to talk about coterminal angles. And if you think about co-anything, if you're on a particular team or in your group or whatever you're in, if you're the co-captain, what does that mean if you're a co-captain?
Like an assistant, like second in command.
Yeah. So and you're sharing it with somebody, right? Yeah. So if you're co-captain, you're sharing. I think somebody said that you're sharing it. Same thing with this one. If you have something that's co-terminal, again, terminal going back to when we're talking about drawing these angles back here. That if we're talking about that's the terminal side where it ends, basically if it's co-terminal angles, these are basically angles that end at the same location. Okay, and we can do this in a couple of different ways. Um, basically, is this to find a coterminal angle of a positive angle? You just subtract 360. And to find a coterminal angle of a negative angle, you just add 360. Okay, so finding coterminal angles is really easy. You either add 360 or you subtract 360. Because if you go 360 degrees in either direction, you wind up exactly at the same place that you started from. So if they tell you, all right, here's one terminal side on this particular angle, and they say, all right, find another way to get there, well, you can either add 360 or you can subtract 360. Because if you move 360 degrees, you wind up in exactly the same spot that you started with. All right, so what we're going to do, we're going to sketch a negative 135 degree angle. And then we're also going to name a coterminal angle. All right, so if we're going to sketch, again, we start with our initial side, which always goes off to the right for this part of it. If you went down to this point, that would be 90. We need to be about halfway in between. So if it's negative 135, it should look something like that. Okay, and then to find a coterminal angle of negative 135, I'm just going to add 360 to that. Which basically means that's going to be 225 degrees. Okay, and the other thing you can kind of visualize too if you're going through this one, you don't necessarily have to write this down. But if you think about what we were doing yesterday, throw this in here real quick and I'll pull this out of the way. If this, because the initial side's kind of both, it's 0 and it's 360. If this thing is going down 135, basically you're starting at 360 and you're going down 135. So that's basically telling you, all right, you're going to wind up at this 225 degree angle that's here. So it's saying you can either go 135 degrees this way and make it negative, or you can go 225 degrees this way and make it positive. So if you just need to know if they give you a negative angle and you just need to know where you're going, just realize again, if it's negative, that means you're going 135 degrees this way. So it's basically like you're starting at 360 and then you're just going to subtract 135 from that and wind up at there. So that's kind of what you want to think about. So again, because the initial side, it can be 0 or it can be 360. So if it's positive, you're going this way. If it's negative, you're just going to subtract that from 360 to know where it is that you're going to go in that direction. Okay, so there's that part we'll cut out. All right, now one stipulation they may have with these. A lot of times with this part of it, they're going to ask you about they're going to ask you to name a coterminal angle. But then they're going to tell you, all right, let's keep this thing between 0 and 360 degrees. And this will go into one of those questions y'all were asking about earlier. What happens if the angle is bigger than something that's on the chart? And we'll kind of show you what that is with this part of it. All right, so what we're going to do is that in this case, let's just give you a couple of these we're going to do. All right, so we're going to name a coterminal angle that's between 0 and 360, and for this one, we're going to do negative 280. All right, so again, if it's negative, really easy to make a coterminal angle. You just add 360 to that angle, and whatever you get, that's your coterminal angle. Okay, if it's 450 degrees, again, you're just going to take 450, and then you're just going to subtract 360 from that. Okay, now here's where we get to the part of where we get some numbers that's maybe a little bit past some of what we're doing for this one. Maybe we're doing negative 560 degrees. All right, so negative 560. Again, we're just going to take that number and we're going to add 360 to it. If you add 360, it comes out to be negative 200. And the directions say it's got to be between 0 and 360. That is not between 0 and 360. So if it's not quite big enough, well, we do the same thing again. We're going to add another 360 degrees to that. And then eventually, adding it a couple of times, we get to 160 degrees. All right, now here's one that's probably going to make you think a little bit because of how it's set up and what's going on for this one. Let's make it negative 11 pi over 6. Because if it's degrees, everybody's usually pretty good at radians. And again, probably here's what you want to do too, and it takes a while. Probably about the time we get finished with this test, you'd probably be comfortable enough that you could start doing this without having to do these things. But basically, here's what we're going to do. If it's negative 11 pi over 6, you're going to go in your unit circle, figure out where 11 pi over 6 is, and go with the degrees in that case, which for that one would be here. That would basically be 330 degrees. So if it's negative 11 pi over 6, just think that's negative 330 degrees. Okay, so that's a negative number. So to make it find coterminal, we're going to add 360 to that. If we do that, we get 30 degrees. Now, that is the answer, but if they give you the answer in terms of radians, you also need the answer in terms of radians. This one's in degrees. So then basically you go to your 30-degree angle, which would be here, figure out that that would be pi over 6. And so then the answer that you get for this one that should be coterminal should just be pi over 6. But again, the kind of shortcut that you get with that one is if they give you negative 11 pi over 6, which was here, if they ask for, or 11 pi over 6, which is here, if they ask for the negative, you're basically just going to go across the x-axis and go straight up to the other number that was pi over 6 there. All right, now, and the other one in the homework that you had that popped up again. And it didn't really ask this, but this is basically what they were doing for this part. I think one of the problems was, I think you said maybe one of the homework problems was asking to find cosine of 19 pi over 4. Well, actually, hang on. We didn't do that. Let's do this. All right, so there we go. Different problem, but we'll kind of tie it back into what we're doing there. So for this one, we'll do 19 pi over 4. And you may be going, okay, but that's nowhere, anywhere on the unit circle. All right, so here's where you can do this a couple of different ways. If they ask you to find like something that's coterminal with 19 pi over 4, the options you have for this one, there's all kinds of different things you can do. I would say probably one option you could do, you could take this thing and change it back into a mixed number. So if you divide 4 into 19, this would be 4, 3. That would be 4 3/4 pi. It'd be okay if we did something like that, maybe? If they give you 19 pi over 4 and you're like, that's nowhere on the unit circle. Okay, I agree. So what we're going to do is we're going to change that back to 4 3/4 pi. All right, now, and we don't have 4 3/4 pi, but here's what we kind of want you to see. If you have 360, it'd be okay that number was 2 pi. So if they give us a number that's obviously bigger than 360, you can just take away 2 pi, and then that would leave you with 2 3/4 pi. Well, that's 2 3/4 pi. It's still too big, so we can take away another 2 pi. So that would leave you with 3/4 pi. And then on your chart, you go back and you figure out, well, where is 3 pi over 4? 3 pi over 4 should be this line right here. So they asked for it in that terms. We're just going to leave it there. We're just going to leave it as 3 pi over 4. So if you can kind of get used to, if we're going to add or subtract 360, if they give it to you in radians, you're going to add or subtract 2 pi to the number. So that's one way you can do it. Now, here's the other thing you can do. If you're okay that this is pi over 4, so this would be 1 pi over 4. If you got to pi over 2, that would be the same thing as 2 pi over 4. Then this would be 3 pi over 4. This would be 4 pi over 4. We knew this was 5 pi over 4. We had 6 pi over 4, which technically was 3 pi over 2, but that would be 6 pi over 4. And then back over here, we had, 7 pi over 4? So you also could count it by pi over 4s. This is 1, 2, 3, 4, 5, 6, 7. This would be 8. Then you would have 9, 10, 11, 12, 13, 14, 15, 16. So you can kind of do it that way. That's 16, 17, 18. This would be the same thing as 19 pi over 4, which will get us back there. So you could do it that way. If they give it to you in terms of pi over 4s, you could just count 1, 2, 3, 4, 5, 6, 7, 8, and just keep going around and around and around till you get to the number that you're looking for. So either way is fine, ever how you get there. All right, now in the homework, what it did ask you, so this is kind of a separate question, but kind of going back to that one, that in the homework, it may have asked you to find the cosine of 19 pi over 4. which means, okay, since these two things wind up the same thing, then really we're going to find the cosine of 3 pi over 4. Which again, if we go back to 3 pi over 4, cosine is the first number, so that would have been negative square root of 2 over 2. So when I ask you to do some of that in the homework, just realize that basically we're going to basically find the coterminal angle with something like this, figure out what it would be between 0 and 360, and then just use that number instead. Okay, then the last, so does that help a little bit? Because again, that popped up in the homework and I didn't realize it was there. It kind of got ahead of itself. But that's basically what it do. It's kind of tied in with this coterminal thing that we're talking about. All right, the last big thing for the day is they're going to give you some problems, or I'm going to give you some problems, where you're going to have to convert something from degrees to radians. But it's not going to be on the unit circle. And we're going to do the hard one first. We'll do the easy one second. So they're going to ask you to convert degrees to radians. So we're going to do one big thing. We're going to multiply by pi over 180. And then you're going to simplify the fraction. Now, and they always say if possible. So far, I don't know that I've seen one where it hasn't been possible. I don't know that you've ever been left with like 37 pi over 180. They always give you some number that you can simplify just a little bit to kind of get there. Okay, so they give you something like this, 40 degrees. And again, these should be numbers that's not on the unit circle. Now, if they happen to sneak up and give you a number that's on the unit circle, that's great because you don't have to do any work. So in this case, all we're going to do is we're going to take that 40 degrees we've got. And you're basically, here's what you're going to do. You're going to make it 40 pi over 180. And then your 40 over 180, that's what you're going to simplify. The very first thing you can do is you can knock out the zeros. Make it 4 pi over 18. Then you can divide them both by 2 to make it 2 pi over 9. All right, they happen to make the number negative. Don't worry, it's not a big deal because you still basically do the same thing. You take the negative 50 degrees you've got and you make it pi over 180. Again, you got some zeros that'll knock each other out. That leaves you with negative 5 pi over 18. And you can't do anything with that one. There you go. All right, give you one more where you can't just knock out the zeros because you'll get some of those occasions where the zeros won't go away. So 222, make that pi over 360. And again, we're going to simplify this number so that we've got the answer with some terms of pi left in the answer. Yes. Yep, my bad. That's not supposed to be 360. Thank you for catching that. That's a 180. Okay, so we got 222 over 180. Obviously, we can divide them by 2. Let's see what happens after that. That is 111 pi over 90. We can divide them by 3. Yeah. I was going to say we couldn't, but I know 3 can go into 90. If you add these up, that's 3. So, yeah, we can divide them by 3. That's going to be 37 pi over 30. And 37 is prime, so we can't do anything with that. So that'll be the answer we're looking for there. Okay, so sometimes the simplifying is going to be easy, like it was here. Sometimes it's going to make you work a little bit to get there. Okay, now of the two, that is the hardest one. If you're like, well, that's not bad. Going the other direction is the easier part. We're going to go from this one. So we're going to convert radians to degrees. Okay, so for this one, we're going to multiply by, we're going to do the opposite that we did before. We're going to multiply by 180 over pi. And after you do that, you're going to use your calculator. So if we have a problem that is 9 pi over 5. So you've got it in radians, which means it's got the pi number in it. You've got to convert it to degrees. So it's 9 pi over 5 times 180 over pi. And where the calculator part comes in handy is if you've got pi over pi, the pi's cancel. So now it's just 9 times 180 divided by 5. Comes out to 324 degrees. Okay. If it happens to not come out to an exact, nice, even whole number, it should tell you to round it off to 1 or 2 decimal places, whatever they kind of specify. So if you have negative 7 pi over 13, we're going to take that number again, multiply by 180 over pi. And again, the whole reason we do that is the pi's will go away, which is what we want. And now it's negative 7 times 180 divided by 13. And that one, if you multiply that out together, round it off, do what you need to do, that should round off to like 96.9. And again, the answer was negative. The question was negative, so the answer needs to be negative also. Again, they should tell you, we're going to round it to 1 decimal place. They should tell you to round it either 1 decimal place or the nearest whole number or 2 decimal places. They'll specify in the question how much you need to round this thing off to. Okay, and the closest thing to a trick question would be something like this, where they give you the radian measure, but they go ahead and take out the pi part of it. So they just tell you it's 4.954 or something like that. Oh, hang on. Wrote the wrong way. My bad. Okay, so again, we're going to take the 4.954. We're going to multiply by 180, and then we're going to divide it by pi. There is no pi to cancel in that case. So, again, it's all calculated question anyway. So we're just going to take 4.954. We're going to multiply by, and the good thing is that a lot of these calculators should have it built in where you have a pi number built in. So after you multiply by 180, you can actually turn around and divide it by pi and use your pi button. Okay, and if we do that, we get 283 point. And again, they should specify how much to go, 283.8 if they say round off to the nearest whole number. Or 1 decimal place would be that. If it was nearest whole number, it would be 284. Okay, and again, they will tell you where to round this thing off to, if it's one decimal place or two or a whole number. They'll specify what they want you to do there. All right, and then the last thing, and this is kind of just a little random little chunk of something that's in here. We just need one place to put it, and this won't take long at all. Okay, you've got to find an intercepted arc. You're going to multiply the radius by the angle. Oh, sorry, let me get that so you can see it there. Your radius is r, which is pretty obvious in that case. Now the angle in this case, they're going to use a theta symbol, which looks like an O with a loop at the top of it, but that's their symbol they're going to use for angle, which is the theta variable or alphabet letter. Okay, and this one again, going to be pretty straightforward on this one. They're going to give you a drawing of a chunk of a circle. And I'll tell you, all right, this is a pi over 2, so that's a right angle that we've got, so it's pi over 2. And they're going to tell you the radius in this case would be at 11 inches, 11 feet. Doesn't matter, just 11 units. And all you're going to do, now here's what they call for the formula for this thing. So the formula that they will talk about is just S equals R theta. So for this example, S, which is your intercepted arc, is just your radius times your angle. And the order you put these in doesn't really matter. Kind of got these backwards here. If you just put that together, that's just 11 pi over 2. And yes, they will let you leave the answer like that where it's in terms of radians, because I don't think they'll ever give you this angle in degrees. It'll always be in radians. So you basically just take the two numbers you've got and you multiply them together. Okay, so for this one, we're going to say the angle is 5 pi over 4, and our radius will wind up being 8. All right, I'm going to do these in the correct order this time because I had these two backwards last time. So this was theta and that was our r. So if it's r theta, it's 8 times 5 pi over 4. You've got the 8 and the 4. You can cancel both of those out. You can divide them both by 4, so you can make that 1 and 2. So that makes that out to be 10